in 7.47, we're to find an expression for the maximum compression of a spring in which a block has been dropped onto it. Okay, so if we have this block at a height h above the end of the spring, which is setting here, that's to be compressed, then as that block falls on this, the spring will move to a lower, the end of the spring will move to a lower position. So I'm going to show that as in a second picture, where the mass has now compressed that spring, so it's shorter than it originally was. Now this is going to compress the spring a distance x. I'll usually like to use x for the parameters showing how much a spring has been compressed, although I know this is moving in the y direction. Now, this block has potential energy above this point, so I'm going to set mu for gravity equals 0 here, so its potential energy is just mgh. It has a mass m. This is going to compress the spring. The spring's going to start out with U elastic. The elastic potential energy it has is 0 at this point, but it's going to compress a distance x and gain some elastic potential energy. So that mass is going to be setting on the end of this. I'm going to put it over here to the side a little bit so you can see it, but it's going to be down here and that spring is going to be compressed. We're given that we have a mass that's a height h above the spring. What we want to know is how much that spring was compressed. Now the theory, of course, is the conservation of energy for this system right here. And you can see that this thing's going to start at with 0 velocity. It's going to hit the spring, going to compress it. And when it reaches its maximum compression, then the block's going to stop again. So there's no kinetic energy at the beginning or the end, okay? So basically what we can look at is here you can see that the potential energy that we start with, U gravitational at the start, must be equal to the energy that the potential energy that the spring gains, the elastic potential energy. So that'll be U elastic final. But also the block has also lost some potential energy. So that will be plus U gravity final. So that's basically the theory behind this. All we have to do right now is just plug in the numbers. So I'm going to go to the solution. And the initial potential energy, gravitational potential energy, is just mgh. And that's going to be equal to, okay, now notice that the block has moved down a distance of x below the 0 point, so it's now going to have minus mgx potential energy. And then, but the spring has gained 1/2 k x squared. I suppose in the given, we probably ought to go ahead and put the K up here. Let's assume that with the spring, we know the spring constant for the spring, so I should have put that up there. Okay, just to be complete. And what we need to do now is basically solve this equation for x. Now, it'll end up being a quadratic equation. So if you will put this in standard form and solve for x, you'll get the expression that the text requires for the value of x. So I'm going to stop at this point and assume that you can solve this quadratic equation here for x.